Let's talk about something we all use constantly, but almost never think about: the invisible energy cost of software. I mean, what if every single line of code, every function had a price tag, but in watts? Seriously, just think about it for a second. How much actual power does it take to send one single email? Or just stream your favorite song? Or just to scroll through your feed? You might be shocked to learn that for most of the digital world, nobody really knows the answer. You see, that energy cost is buried deep inside these massive, incredibly power-hungry data centers. And the real kicker? The companies building all the software we use are, for the most part, totally flying blind. They literally can't tell which parts of their software are efficient and which parts are just energy guzzlers. It's a massive blind spot. So how in the world do we fix a problem we can't even see? Well, here's our game plan. We're going to start by digging into this hidden energy problem. Then we'll look at a new kind of tool, a ruler for code. We'll break down the 3 core metrics that make it work, see how the formula creates a final score, and then the best part, see how to put that score to work. It really just boils down to one of the oldest rules in the book. You can't manage what you don't measure, right? If companies have no way of seeing the energy footprint of each little piece of their software, they've got no control. Not over the environmental impact, and not over the financial cost of their own digital infrastructure. And this is where the big shift has to happen. It's about moving away from just guessing and hoping for the best. A new standard is trying to make sure that, and I'm quoting here, decisions are driven by measured energy and business impact, not guesses. It's about time, right? Okay, so how on earth do you measure something as abstract as the energy cost of code? I mean, you can't just use a hammer or a wrench. You need a totally new kind of tool. What you really need is a ruler for code. And that ruler has a name, the HRM01I standard. Its whole mission is to create one single standardized score. They call it an energy index for every single piece of software. You can think of it like a universal nutrition label, but for code. It lets you compare everything, apples to apples. So how does this ruler actually work? What's it made of? Well, it's built on 3 really simple but powerful core metrics. Let's check out the building blocks that come together to create that final energy score. Okay, first up is activity. This one's easy. It's just a measure of how much a piece of software gets used. Let's pretend our software is a big workshop full of tools. Activity is just asking, how often are we using this specific tool? Is it running once a day or maybe a million times a minute? That's activity. Our second building block is intensity. This measures how much energy is used up every single time that function runs. So back in our workshop, this is all about the power draw of the tool itself. A small cordless drill and a giant industrial table saw might both get used just once, but their energy intensity, yeah, they're in completely different universes. And the third piece of this puzzle is structural criticality. This metric is fascinating. It basically asks, how important is this tool to the entire workshop? Is it some rarely used specialized screwdriver, or is it the main power saw that the whole operation completely depends on? In software, this is all about how many other systems rely on this one function to get their jobs done. Okay, so we have our 3 building blocks: activity, how often something runs; intensity, how much power it draws; and criticality, how important it is. Now let's see how they all get combined to create that single, meaningful score. The calculation, believe it or not, is actually pretty straightforward. First, you get what's called weighted energy by just multiplying our 3 metrics together. Simple enough. Next, you need something to compare it to, so you establish a baseline. You just find the median energy use for a whole group of similar functions, and you call that baseline 100. Finally, you just compare your function's energy to that baseline to get your final index. So you run all the numbers, and poof, out pops a score. Let's say, just for example, your software function gets an energy index of 150. So what? What does a number like 150 actually tell you? It's actually super intuitive. The index gives you an instant, easy-to-understand comparison. A score of 150 means that this piece of code uses 50% more weighted energy than the average baseline function. And if you got a score of, say, 50, well, that means it uses half the energy. All of a sudden, this abstract problem has a concrete number you can actually work with. Now, knowing the energy cost is a massive leap forward, but it's really only half the story. The real goal here is to understand the value you're getting for that energy cost, and that is where the efficiency score comes in. This is where it all comes together. The efficiency score is brilliant. You just take the business value a function creates, and that could be anything the business cares about, like revenue or customer signups, and you divide it by its energy index. The goal is simple. Get the highest efficiency score you possibly can. And this is the end game, right here. You are hunting for functions that give you high business value for a low energy cost. That's the sweet spot. The opposite, low value for a high energy cost, is a huge red flag. This score makes it incredibly easy to spot the dead weight that needs to be fixed or maybe even just retired. This isn't just some theoretical idea on a whiteboard. This standard gets enforced with real governance. There's a master catalog called the Book that lists all the software and its energy profile. Then those scores are built right into the daily workflows for developers. It makes energy awareness just part of the company's DNA. So when you boil it all down, what this standard really does is take this huge, abstract, invisible problem, the energy drain of code, and it turns it into something you can measure, something you can compare, and something you can actually govern. It makes the invisible visible. And that leaves us with one last big question to chew on. Just imagine for a moment if every single piece of software we used, from a tiny button click on a website to a massive AI algorithm, had a clear public energy rating. How do you think that would change the way we build, buy, and use our entire digital world? Something to think about.